For this video, we'll be talking about the trig substitution unit. This is 8.4. And trig substitution is something you're going to use it's basically u sub except with trigonometry. And for this, you're going to look for specific patterns. For example, the square root of a squared minus u squared. In that case, you're going to use trig substitution with sine theta. U equals a sine theta. The reason for this is your triangle. If you take your triangle with your opposite side of u, and this is your theta, opposite side of u and your hypotenuse of a, satisfying this equation, your missing length is going to be this term here. And repeat that with square root of a squared plus u squared. In that case, you're going to use u of a tangent of theta, and again, u, a, and your missing term is satisfied using the Pythagorean theorem. And lastly, you're going to use secant theta for the term u squared minus a squared, satisfying your opposite side length in this triangle, with theta being the closest angle there. And the reason all this works is simply because Pythagorean theorem states cosine squared theta plus sine squared of theta equals 1. And that can be used to derive all of these terms and used for these three key functions. Now, in this practice problem, this is from the review section, and it is number 28. In this practice problem, we're first going to observe, okay, which trig substitution should be used? Well, looking at the terms, we see this looks like a squared minus u squared, which in that case, we're going to use u equals a sine of theta. Well, here we have our a squared term, and here we have our u squared term. That's making 3x equals 5 sine theta. That's because we take the square root of that, plug it into this equation here. And from there, we're going to want to solve for our x value, which equals 5/3 sine theta. And from here, when we have x equals 5/3 sine of theta, we take the derivative of both sides, dx equals 5/3 cosine of theta d theta, taking the derivative of what's in your trig function. From there, we need to we can go ahead and solve for our x squared, which we will be using soon. So 25/9 sine squared of theta. Now from there, we want to take our original equation and replace our newfound variables into the original. So we have the derivative, square root of 25 minus 9 times our x, which 9 times x squared will be 25 sine squared theta. And then we have to multiply by dx. Well, dx we found here to be 5/3 cosine theta d theta. And from there, we recognize that, pull out a 25 here, so that's 5. So in the end, we're going to have 25/3, leaving us with 1 minus sine squared, which is the square root of that, is cosine squared, leaving us with cosine squared theta d theta. From there, we recognize this and realize cosine squared theta equals 1/2 1 plus cosine 2 theta. Well, using that, we can take the derivative of this term, not this one. So, we'll pull out a 1/2, 26 or 25 over 6, the derivative, or the integral of 1 plus cosine of 2. So from here, after pulling out your 1/2, you recognize that this is nearly 25 1 times theta plus theta plus the integral of 25 times 6, 25 over 6 of cosine 2 theta d theta. Well, this is, integral of this is 1/2 sine of 2 theta, so plus 25 over 12 of sine 2 theta plus c. Theta. Well, from here, that's the correct answer. However, we need to convert this back to x's and our original, back to our original terms. So from there, we see that here 3x over 5 equals sine theta, meaning theta equals the arcsine of 3x over 5. So we have 25 over 6 times inverse sine of 3x over 5. And here we need to manipulate this, getting rid of our 2 theta. To do so, we're going to use our trig function. Sine of 2 theta equals 2 sine theta times cosine of theta. So to do that, we get plus, plug that back in there, 25 over 6 sine theta cosine theta plus c. Once we do that, we need to go back to our original triangle that we created, which was from theta. Here we have 3x, 5, well, this is 25 minus 9x squared. Simplifying this, we find sine of theta to be our 3x over 5. So 3x over 5, and while cosine of theta is the square root of 25 over 5 as well. Well, multiplying that together, multiplying our constant together, we end up with 25 over 6 inverse sine of 3x over 5 plus 1/2 x square root of 25 minus 9x squared plus our constant c. And that is our final answer to the integral of the square root of 25 minus 9x squared.